What if everything we thought we knew about oxygen on Earth is wrong? What if the very element keeping us alive has a secret source hidden in the ocean depths? The deep sea is Earth's final frontier, less explored than the surface of Mars. But a discovery has shocked scientists worldwide, challenging our understanding of how life itself might have begun. Today, we dive 4,000 meters below the waves to uncover dark oxygen, a phenomenon so alien it could rewrite our understanding of life on Earth and beyond. Between Hawaii and Mexico lies an abyssal plain known as the Clarion Clipperton zone. This vast underwater desert stretches across 4.5 million square kilometers of seafloor, larger than the entire European Union. Here, scattered across the ocean floor like forgotten treasures, lie billions of potato-sized metallic nodules. These unassuming rocks have caught the attention of mining companies for their rich deposits of manganese, nickel, copper, cobalt, and lithium, metals crucial for our green energy future. Despite its crushing pressure and eternal darkness, the CCZ teems with bizarre life forms. Xenophyophores, giant single-celled organisms with alien-like structures, blanket the seafloor. Translucent fish with distended jaws patrol the waters while ghostly squid drift through the abyss, all surviving in an environment more hostile than Mars. But these nodules hold a secret far more valuable than rare metals. In 2013, deep-sea ecologist Andrew Sweetman deployed sensors to the CCZ seafloor to measure oxygen consumption. His instruments returned puzzling data. Instead of consuming oxygen as expected, the seafloor was producing it. At first, Sweetman dismissed the readings as instrument error. Every scientist knows oxygen production requires photosynthesis, a process that needs sunlight. At 4,000 meters deep, no light penetrates. But when the same readings appeared in subsequent expeditions, Sweetman could no longer ignore the evidence. Something in the eternal darkness was generating oxygen. The source? Those same metallic nodules that mining companies were eager to harvest. Could the secret to alien life be hidden beneath our oceans all along? What if everything we thought we knew about where life can exist is about to change? To understand how these nodules produce oxygen, we need to understand electrolysis, the process of using electricity to split water molecules into hydrogen and oxygen. Typically, electrolysis requires external power, but these nodules act as natural batteries. Over millions of years, different metals accumulate in uneven layers, creating a voltage difference across the nodule surface, approximately 0.95 volts, similar to a standard AA battery. When multiple nodules touch on the seafloor, they form a natural circuit. This gentle electrical current is just enough to split seawater into oxygen and hydrogen gas. Some skeptics, including mining companies like the Metals Company, initially dismissed these findings as sensor errors or trapped gas bubbles. But Sweetman's team devised a definitive test. In laboratory conditions, they replicated the deep-sea environment and used mercury chloride to kill all microorganisms. The oxygen production continued unabated, proving conclusively this was a purely chemical process generated by the nodules themselves. Scientists have named this phenomenon dark oxygen, oxygen produced without sunlight or living organisms. This discovery challenges our fundamental understanding of Earth's oxygen cycle. For centuries, we believed all oxygen originated from photosynthesis, plants and algae harnessing sunlight to convert carbon dioxide into oxygen. But what if there's been another source operating in darkness all along? The implications extend far beyond our planet. If oxygen can be generated without sunlight, could similar processes be occurring on other worlds? Consider the moons Europa and Enceladus, both with vast liquid water oceans beneath icy crusts. Scientists have long wondered if these dark oceans could harbor life. The oxygen requirement was thought to be a major obstacle. Without sunlight, how would oxygen be produced? According to NASA's Europa overview, Jupiter's radiation splits water molecules in Europa's ice through a process called radiolysis. But dark oxygen suggests a second mechanism could be working in tandem. If metallic deposits similar to Earth's nodules exist on Europa's seafloor, they could be generating additional oxygen, potentially creating habitable pockets where strange, squid-like creatures might evolve, completely disconnected from the sun's energy. This oxygen may be sustaining eerie deep-sea ecosystems we can barely imagine. Creatures adapted to eternal darkness, extreme pressure, and a chemical environment more alien than anything we've encountered. Mining companies see these nodules as green energy gold, critical resources for transitioning away from fossil fuels. But removing these natural oxygen generators could disrupt ecosystems we barely understand. Over 800 marine scientists from 44 countries have signed a petition calling for a pause on deep-sea mining until we better understand these environments. The International Seabed Authority is currently developing regulations that will determine the future of these nodules. We need to explore in greater detail, Professor Sweetman argues. Before we mine the deep ocean, we need to understand it. The discovery of dark oxygen forces us to reconsider one of science's most fundamental questions. How did life begin on Earth? For decades, scientists believed Earth's oxygen surged with photosynthetic bacteria about 2.4 billion years ago in what we call the Great Oxidation Event. But what if there was another source? Could dark oxygen have provided early pockets of oxygen in the primordial oceans, fueling life even earlier than we thought possible? These nodules might have created oxygen-rich environments on the early Earth, potentially serving as incubators for the first complex organisms long before photosynthesis evolved. The discovery has caught NASA's attention. If rocky materials can generate oxygen through natural processes, we may need to rethink where we search for life beyond Earth. Planets and moons previously considered too dark for oxygen production might still harbor the conditions necessary for life. As our understanding of dark oxygen grows, one thing is certain: the deep sea remains Earth's most alien environment. Just 150 years after humans first discovered the deep ocean's existence, we're still uncovering its fundamental secrets. The Scottish Association for Marine Science has secured £2 million in funding to deploy specialized sensors to further investigate dark oxygen. These will be the first UK-based instruments capable of sampling below 6,000 meters, allowing us to explore whether this phenomenon extends even deeper. The ocean's darkest depths may hold the key to understanding not just our own planet's history, but the potential for life across the cosmos. In the search for alien life, we need look no further than Earth's own alien realm: the mysterious deep sea. What other secrets might be hiding in those unexplored depths? Only time and further exploration will tell. Subscribe now for more deep-sea mysteries that challenge our understanding of life on Earth and beyond. Do you think dark oxygen could be supporting alien-like creatures in Europa's oceans? Comment below with your theories.